In this tutorial, we'll discuss in detail RTC IC, which is DS1307 with 8051. Now, this is going to be a fairly long tutorial, and I recommend you to go through the I2C basics before you go ahead with this tutorial. So the DS1307, it works on the I2C or the TWI, two-wire interface protocol, and this we have discussed in depth in another video. You could watch that. So basically this protocol has two wires or two lines, SCL and STA, and the protocol defines various stages for the start condition, the stop condition, the start byte, the acknowledgements, positive and negative. So all this you could go through in the previous tutorial. So in this tutorial, even though it would cover all of these, it's highly recommended that you watch the basics video. Now let us go ahead and look at the actual IC. Now, this is how the DS1307 looks. So we have the two ground and VCC pins, and there is a pin for the battery. So here you can connect a coin cell, a CR2032. So if this is positive and this is negative, this can go to ground, and the entire board can be turned off, and this IC will get power from the battery, the coin cell holder, and then it can keep time all the way. Then there is also a crystal which is required to be connected, and this crystal needs to be connected on X1 and X2. Now these are the pins that we are talking about. So SCL is the serial clock for the I2C, and SDA is serial data. So with these two pins, and the IC communicates with the 8051 microcontroller. There is an optional square wave output pin on the IC which generates a square wave, which could also be used to measure count time, but we will not be discussing that. So what this IC basically does is, so it has a RAM structure like this, or basically the internal address structure like this. What it does is, so if you could observe from 0 and then they go to 3FH. So this is 8-bit wide, so this is 8-bit. So what happens is, on the 0th location it stores the seconds, then on the first minutes, hours, and then the day, and also it stores date, month, year. So you can make a complete calendar out of this IC. So, and just remember how these numbers, the addresses on the back of your mind. So especially the second starts at 00, and the first 3 places would give us time. So this would be seconds followed by minutes, and this followed by hours. And remember the sequence as well. So the address for seconds is 00, this is minutes is 01, and hours is 10, or it is 2 in hex. So this is 10 in binary, so that would be 2 in hex. So hex, it would be 0x01, 0x02, and 0x03. And also note that the date starts from 0x and 0x04. So this is 01, 02, 03, 04, this is 05, 06. So the time would be locations 1, 0, 1 and 2. Sorry, this is 0, this is 1 and 2, and the date starts from location 4. this is TD, MM and YY. So, and the location for this would be 040506. So whenever you read or write time from microcontroller, the address should be this. Okay, so let us go ahead and look at the communication protocol. Now this is format to write to. So what we need to do is we need to send a start condition or a start bit, which should say in a little while. So we'd send a start bit, and then we would send this particular address. So this is 7 bits, so it is 0x in decimal. This is 7 bits plus a read write bit. So if I count that, this would be D0. Now, and in this case, what you could find is the D0 is 0. That means read/write bar is 0. So it would be configured in write mode. So the microcontroller can write into the RTC IC. So, and this is followed by an acknowledgement. The DS1307 sends an acknowledgement that it has received the correct address. Then it is followed by the address of the control register, or the address of the minutes, seconds or hours which we discussed. And if it is a write operation, and say we send the address 00, which is for seconds, then we go ahead and write these seconds into the memory, and that is stored. That is again followed by an acknowledgement, and the process continues. You could observe that one write operation is of 8 bits or 1 byte. Okay, and let me pause here and give you a brief of how this will be done. So what is done is, first we initialize the RTC and then on the RTC. So what we do is we initialize it and we write date and time, and next time whenever we need the date and time, it is written only once, and then we do not require to write it again. So once the date and time is set, the RTC starts ticking on its own, and then whenever we need time, we read it. Now, so what we saw was how we could write into the RTC. Similarly, to read it, so to read the time or the date, what we need to do is when sending the first byte, or this is often called as ID, device ID, and it is specific to this particular RTC. So we send this device ID, and in this case we make the read write bit 1. So this would be 1, 0x D1. So we send that byte, and then we send whatever we want to read. To read seconds, we send 00, and then the next byte would read, next operation would be a read operation, and that would read the seconds from the memory. So this is how this is the basics of it, and we'll go ahead and look at the schematic diagram now. As discussed before, and since 8051 does not have internal hardware to support I2C, we can connect it to any of the 2 IO pins, and then we can bit bang it. So we write the entire protocol in software, and we send data bit by bit. So the SCL, the square, the clock is connected to pin 3.6, and the data is connected to pin 3.7. These are the only 2 connections that are required. And what we do is, there is also a battery and a crystal that is required to connect. Then what we do is we have connected LCD on port 1, and what we do is we read time from the RTC and then we display it on the LCD. So this is fairly straightforward task to do. Now before we go ahead and look at the actual code, let us just go through the basics of I2C. Now what we have done is we have written a set of functions for I2C. Now these functions are used by the DS1307 library. Now what this does is, since I2C is used for most of the, for many ICs, what this does is it separates I2C from DS1307, so that any other peripheral which works on I2C can also make use of the I2C library. So the I2C.c, this file, it contains all the library functions which implement the I2C protocol, and I2C.h is the header file which shows all the function prototypes in I2C.c. And then we have DS1307.c as a file which basically does the data read and the data write operation, and also initializes the RTC. And there is a DS1307.h file which has all these prototypes. So let's go ahead and look at the protocol first, and how we could bit bang and write the I2C with 8051. Now this is the header file for the I2C, and it has various functions. So the first one, it generates a clock. So as discussed in the I2C video, the clock needs to be generated by master, and in this case 8051 is the master, and it generates the clock. So what this function simply does is it generates a one cycle or one complete pulse every time it is called. Okay, and then I2C start, it generates the start condition for the protocol. Then I2C stop generates stop condition for the protocol. I2C write, as you can see, it takes a char and then it writes it to the IC. And now you should be knowing that the SDA line, it's like, say we want to transfer 0xAA, which is 10101010. Now this is one character which is given input to this. Now what I2C write function does is it spits out MSB first. What it does is it makes the SDA line 1, and then it spits out from MSB one by one. So the function basically writes out 1 bit at a time. So it writes total 8 bits or a character. Similarly, I2C read function, it takes the data serially which is coming on the data line, and then it makes a complete byte and returns the byte. So as you can see here, there is no input to this, but it returns a byte which is coming on the I2C bus. Now I2C ACK is a positive acknowledgement stating that the byte is successfully received. NAC indicates it is not received. So we'll look at each of these functions now. Now before we look at the functions, you could observe that in the I2C file, what you have is I2C.c, what you have is port. As in the schematic, the SCL is configured as port 3.6 and SDA is configured as port 3.7. Now we'll go ahead and look at the functions that we have set here. So first we start with I2C clock. So what it simply does is high for a microsecond, and then it goes low for a microsecond. So actually the frequency it generates, it's not megahertz, because the RTC works on much lesser frequency, and the delay underscore microseconds if you are following along. So it generates not 1 microsecond, but for every count we give here it generates 10 microseconds. So it is a total of 20 microsecond of pulse which the clock generates. So it's a pretty simple function. Now the next is the start condition. Now if you remember from the I2C basics video, a start condition is when when the clock is high, and we pull down the data line. So all the other transitions except the start condition and stop conditions, they occur when the clock is low. So and only the you could call the protocol commands, these happen when the clock is high. So in this particular case, when the clock is high and the data line goes from high to low, it generates the start condition, and that is what is done on the code. It is ensured that the clock is low initially and the data is high, right? So that the transition can in fact occur. Then what we make is we make SCL high, and then after a microsecond we pull the STA low. So what it does is it generates this pulse, and then we wait for a microsecond and then we go back. So this is the start condition. Similarly, the stop condition would be a low to high pulse when the clock is high. Again, only the start and the stop condition bits, the transition happens when the clock is high. Okay, so when the clock is high and the SDA pin goes from low to high, it generates the stop condition, and this is the function that implements the stop condition. Now going ahead, the next obvious thing would be to write using the I2C line. Now as said earlier, what it does is it takes say 8 byte, as you said, 8 bits, and then it transfers 1 bit at a time. D8, the MSB goes first, then the D7, D6, D5, D4, D3, D2, and all the 8 bits. So to do that, what we do is we loop from 0 to 7, which is 0 to I less than 8. So this does it for 8 times, and what it does is whatever data that we need to transmit, it is taken and it is ANDed with 80 in hex. So what it does is, say for example we have this as a data which needs to be transmitted. So what it does is it ANDs with 80. So what remains is only this. So if this bit is 1, the result is 1. So now if the result is 1, it puts that onto the SDA line, and then it generates a clock pulse that we discussed, and then this data is copied. It is not modified here, the STA line is modified. So this data, it is shifted again for the next time. So next time it is right shifted by 1. So this 0 comes to the next position, this 1 comes here, this 1 comes here, then we have a 0, then we have a 0 and a 0. Now we have the next bit. Similarly, we cycle it 8 times to transfer the entire 8 bits. So similarly, in a read operation, what we do is instead of transmitting, we take 8 bits serially, one at a time. So this is function for I2C read. Now what we go ahead and do next is there's 2 more to go before we could discuss DS1307. So acknowledgement, as we know, to send a positive acknowledgement when the clock is high, if we pull the data line low, so this sends a positive acknowledgement. Similarly, for a negative acknowledgement is high, when the clock is high and we make the pin high, we make the data line high, it generates a negative acknowledgement, or it is called no ACK. Okay, now we will use these functions, the I2C functions to interface RTC, and these are the function prototypes for the RTC. The RTC init function, what it does is it sets the address for the RTC and then it disables the square wave out. So if you remember from the schematic, there is one pin which produces square wave, so we do not require that, hence we turn it off. So, and I will see that in detail. And this DS1307 write, what it does is it uses I2C write function and then it writes a character. Similarly, DS1307 read uses I2C read and receives a character. And these are the next four important functions. RTC set time, it sets the time, it writes time to the RTC. Similarly, the next function writes date, and then the next two functions, if you pass a pointer, you can note the difference here. If you pass 3 character pointers to the first function, it gets the time and the date, in time in mmddyy format and date in time in seconds, minutes and hours, and date in mmddyy. So we'll go ahead and look at these functions now. Alright, so we'll go ahead and look into the the DS1307 functions in the next video.